The cubic unit cell structure of a compound containing cation M and anion X is shown below. When compared to the anion, the cation has smaller ionic radius. Choose the correct statement or statements. This is the structure given. Option 1. Empirical formula of the compound is Mx. Option 2. The cation M and X have different coordination geometries. Option 3. The ratio of Mx bond length to the cubic unit cell edge length is 0.866. The ratio of ionic radii of cation M to anion X is 0.414. So we have to consider the options one by one. And first let us take option 1, that is the empirical formula of the compound is Mx. So this is the given structure. The white spheres are X and yellow is M. X atoms are on the edges and shared by 4 unit cells. So these X atoms are shared by 4 unit cells and M atoms on the base ends are shared by 2 unit cells only. Therefore, the effective number of X atoms will be 1 by 4 into 4. There are 4 X atoms. So the effective number will be 1. Effective number of M atoms per unit cell will be 1 by 2 into 2, that is 1. That is only 2 M atoms are there and each M atom is shared by 2 unit cells. So therefore the empirical formula must be Mx. So that is 1:1, hence it is Mx. So option 1 must be a correct option. Next we consider option 2. The cation M and anion X have different coordination geometries. So this is the given structure. These are X atoms. These are M atoms. Now I am placing another unit cell side by side. Now look at the unit cell that I have created. So this red unit cell, that also is a unit cell. Now in the red unit cell, the M atom is at the center and it is surrounded by 8 X atoms. So therefore the coordination number of M must be 8, or the M ion is surrounded by 8 X ions. So the coordination number of M is 8. Now I have marked one X atom, that is marked red. Now this is shared by 4 unit cells. Another from above, then bottom, so this one. So this marked X ion is shared by 4 unit cells. Now imagine another unit cell created in this way, that is this green unit cell. So in that unit cell, the X atom is at the middle. Now it is touching 1, 2, 3, 4, 5, 6, on the back side 7 and 8. So each X ion touches 8 M ions. So the coordination number of X also is 8. And that is each M is surrounded by 8 X atoms and each X atom is surrounded by 8 M atoms. Therefore the coordination numbers of both are 8. Therefore option 2 must be incorrect. The cation M and X have different coordination geometries. They have the same coordination geometries. And now we have to consider the third one. The ratio of Mx bond length to the cubic unit cell edge length is 0.866. Imagine a small cube within the unit cell. So this atom is M and this atom is X and this distance will be A by 2. So Mx is the length of the body diagonal of the small cube. Now body diagonal is root 3a, and here it is a by 2, that is edge length, so it is root 3a by 2. Hence the ratio mx by a, mx is equal to root 3a by 2 divided by a, and that is equal to 0.866. So option 3, the ratio of mx bond length to cubic unit cell edge length is 0.866, so it should be a correct option. Now we have to consider the fourth option. The ratio of ionic radii of cation M to anion X is 0.414. Now I am placing another unit cell side by side of this one. Now imagine this red unit cell. And in the red unit cell, the M atom is at the center. And this distance is A, edge length. So this is same as this one. Of course, these X atoms must touch each other. In this structure, the M ion reside in the cubic void formed by the X ions. Now, if you look at the small cube, actually this M ion and X ion must touch each other. So this mx distance will be radius of the M ion plus radius of the X ion, and that is the body diagonal of the small cube. So therefore we can write Rm plus Rx is equal to root 3a by 2, and this is equal to 0.866a, and a is equal to 2Rx. So therefore Rm plus Rx is equal to 0.866 into 2Rx. Now just divide this equation throughout by Rx. That is Rm by Rx plus Rx by Rx, 0.86 by 2 Rx by Rx. And this Rx and Rx cancels, and this will be 1.732. Rm by Rx, then this cancels, so that is 1.732. Now Rm by Rx is equal to 1.732 minus 1, that is 0.732. That is the radius of the M ion by radius of the X ion is equal to 0.732. But in option 4 it is given as 0.414. So option 4 must be incorrect. So option 1 and option 3 are the correct options.